Assalamualaikum to Dr. Hairul. My name is Akil bin Ma'adin from Group 4 and I will explain a bit introduction of our topic, which is measuring river velocity. River velocity is really important in hydrology because it could determine the water quality, it could determine what kind of living organisms that lives in the water, and it also could determine the amount of silt that got carried by the stream. So we have chose three common methods to measure river velocity, which are acoustic Doppler current profiler. Second one is remote sensing method, and lastly particle image velocimetry, and this method will be explained in details in comprehensive review.
Okay, so hi, my name is Nur Ashikin binti Muhammad Azari and I will present about the acoustic Doppler current profiler ADCP method. Okay, so what is ADCP? ADCP is used for measure of velocity and discharge technology of using acoustic signal and Doppler frequency. Okay, so this is the instrument of ADCP, which is TRDI instrument. TRDI. Okay, so ADCP consisting of the TRDI stream pole use more than one acoustic reducer to determine the velocity of a fluid by the analysis of the Doppler shift. Okay, so method of ADCP. The ADCP is placed in a stationary position above the flume such that the instrument was placed in the middle of the flow that facing downward. Okay, so the immersion of the ADCP probe in a flow was also changed from 1 cm to 1.75 cm to achieve the best positioning of the sample of the volume. So the ADCP is used to record the velocity measurement along the vertical profile. Meanwhile, the LDA is used to make a series of vertical measurements centered on the center of each of ADCP 1 cm vertical increment.
Assalamualaikum dan salam sejahtera. My name is HERYANI ARFIDA and I will present about remote sensing method. What is exactly is active remote sensing? Active remote sensing source of energy is part of the remote sensor system, which is radar and lidar. Active remote sensing instrument generate their own emission or light. Passive one rely on reflect light. An instrument for active remote sensing have 6: radar, lidar, laser altimeter, ranging instrument, sounder and spectrometer. Application and advantage of remote sensing method is fully function at any time of the day, relatively independent of atmospheric scattering. And data acquired with remote sensing instruments serve agriculturers and foresters. They are critical in hard-to-reach places in marine, science and rescue mission. Sounder assists in developing weather forecast with vertical profile of humidity, precipitation, temperature and presence of cloud. What is exactly passive remote sensing? It depends on natural energy, sun rays, bounced by the target. Employs multispectral or hyperspectral sensor that measure the acquired quantity with multiple band combination. Passive remote sensing device have 7, which is spectrometer, radiometer, spectroradiometer, hyperspectral radiometer, imaging radiometer, sounder and accelerometer. The most popular passive remote sensing example of device are various types of radiometer or spectrometer.
My name is AMIRUL Falah and I will present about thermal image processing in PIV method. This is the picture of deployment of the FLIR SC8340 mid-infrared thermal camera from a mobile platform along a bridge across the Salcha River. This method is carried out by, number 1, the resulting surface velocity were converted to depth average velocity by applying site specifics. Number 2, five spectra from 3 clear flowing streams provided strong relationships between depth and reflectance, suggesting that under favorable condition, spectral-based vectometric mapping could complement thermal PIV in a hybrid approach. Number 3, a more flexible and efficient alternative might involve inferring depth from thermal database on relationship between depth and integral length scales of turbulent fluctuation in temperature captured as variation in image. Number 4, we observe a moderately strong correlation for a site aggregates data, set the reduced station to station variability by encompass a broad range of depth. Number 5, discharge calculated using thermal PIV derived velocity were within 50% of in situ measurement when combined with depth measured directly in the field or estimated from field spectra, and within 40% when the depth information also was derived from the thermal image. This is an example PIV result derived from thermal image time series acquired from a bridge across the China River, which is diagram A is initial output from PIV lab consisting of a 1449 array of pixel displacement, and diagram B is velocity vectors obtained by using the camera frame rate and spatial image dimension to convert from pixel frame to m per s meter per second, and then averaging in the streamwise direction and over time. And diagram C is the spatially and temporally average mean velocity vector used to calculate discharge.
Hi, my name is Muhammad Alif Irwan RUSNAN. Today I'm going to talk about recommendation. In this project, we have three types of method. Firstly, PIV. In PIV, we need to increase the flying height. In order to we can achieve from this, airborne data collection might provide image data with sufficient extent. Second, ADCP. The ADCP time of measurement that will be impact the measurement accuracy, the impact of transient time and number of transects on the accuracy of the flow measurement with ADCP. Lastly, remote sensing method. We need to understand the level of accuracy associated with particular product. In conclusion, river velocity plays a huge role in ecosystem because of its importance in numerous hydrological and geomorphological research questions to comprehend the characteristics of catchment and their adaptation to climatic change. We have three different types of method, which is ADCP, PIV, and remote sensing method. All these three methods use different style of measurement in order to measure the river velocity. That's all from me.